Hello everyone, welcome to the first Colette Module. It will give you insight into our mobile app. You will get to try it out and learn about its background. This is the first module of a series of 4 about computational thinking. The Colette-Project is founded by the European Union and composed of people from 9 institutions in Europe. My name is Christian Mercat, and on behalf of the whole team, I welcome you to this first module and will go through the agenda after a short ice-breaking activity. Please go ahead, open your devices and follow the link or QR codes to try out these ice-breaking tasks online. You can work in groups, but there should be one device per person, as everyone should get to try it out directly. I will be here to support you if you run into problems, and I also have some spare devices if you need it. We provide 3 tasks in total to make sure everyone finds something interesting to test and try out. Click View and slowly scan or hover over the marker to see in augmented reality what your code produces. You have to hover slowly over the marker which is on this slide. I also provide you with printed version of the marker so that all of you can then utilize the augmented reality function of the mobile app to view your solution. So you have to select and check View your solution and accept access to camera and slowly over the city marker or turn the city marker with your hands when it's printed. You will view the result of your code in augmented reality. What you just experienced is solving tasks that address computational thinking. We did some coding in an online environment. In Colette, we have created an application on smartphone that you can introduce to your students, where students encounter a sequence of tasks, what we call a path. They can work in groups or pair and discuss the task that they receive. The feedback will be either automatic or given by peers or teachers, or a mix of all that. Students will be able to view the output of their code using augmented reality. And just like we do today, you can discuss the task with your students. Our agenda today. We'll continue and download the app. After the installation procedure, you can try out some predefined tasks in this module. Afterwards, we'll discuss your ideas and thoughts regarding the app and the Colette tasks. We'll finish this module with some background about computational thinking and Colette. There will be also some time to answer your questions. What is an educational application? An educational application or learning app is defined as a digital resource that supports learning within the framework of school lessons and independent interest-based learning, in which students or educators use mobile devices such as a smartphone or a tablet to develop, practice, deepen, repeat and structure content or to pursue their own areas of interest. Additionally, those apps are often more specific and up-to-date than printed textbooks, whereas information is available more quickly and easily, virtually everywhere. The design, the tasks, and the structure try to simplify the learning process intuitively. Furthermore, displayed exercises often provide immediate feedback. In addition, helping the user to learn automatically supports their independence in a time-saving and fun way. So in fact, we'll be focusing today on the application that we made for students. However, Colette also includes a web portal for teachers, various tasks, training and handbook that will be covered in later modules. In this step, students should download the Colette app. There are two different ways for iOS and Apple on and Android devices. If you are on iOS, please install the app using the instruction on the left side of the slide. If you are an Android user, please check the right side of the slide and install the app from the Play Store. So now that you have downloaded the app, you might still be asking yourself, but what is Colette? The main idea is to provide you with a learning environment that contains various tasks that students can try out and develop their computational thinking skills regardless of their socio-economic background. What you see on this slide are icons representing the 8 tasks families or task types that the app has to offer. We'll try out the student side using the Colette app in this module, and in the next module you will get to know the teacher side, the Colette web portal, where you, as a teacher, can tune the tasks and the way they are sequenced. By using the app with your students, you increase the presence of computational thinking in your classroom. Here are some screenshots from the mobile app that you just started using. To open a path, click on the plus button. To enter the correct code to your path, in this example path, please use the code P5416. Then click Add. After inserting the correct code, the path appears. It is named Colette Introduction of App and Web Portal. In this example, please click on the path. It consists of 3 example tasks. Then click on Start, and then on the first task in the path, here named Task 1, L-shaped. You can see what the students will see on their smartphones. After clicking on the first task, by clicking on cubes, you will get the available commands for initializing and setting blocks. Same thing in the section Controls, with loops and conditional. These commands are to be dragged and dropped on the canvas. Here there are manifold options and features of the app. You can of course zoom in and out of the code, you can delete blocks, you can show or hide task description and hints, you can test the code with augmented reality, and you can go back to the list of tasks. You can view the image solution again. We can of course center the code on the canvas, which can be very large. You can undo or redo the last thing. And you can finally get a feedback whether you have succeeded or not by checking the final solution. In the app, students have the opportunity to check their results using augmented reality, or AR for short. The learners can see their current result live. All they need is the AR marker, the CT-AR marker on the left. First, the students have to press Test, possibly allow access to the device once and for all, and then point the camera at the marker. This way, the students can see the result live. They test it live and know immediately whether their solution is correct or on the right track or not. The target solution appears blurred and transparent. By visualizing step by step the solution, students can immediately check and see whether they are on their way to solve the task or not. For example, here there are already 3 different commands for placing blocks. The first block is placed at coordinates x is equal 3, y is equal 2, and z equal 1. As you can see with the augmented reality test, it is not well placed. If you want to change this y value, which is obviously wrong, Click on the chosen variable and put it in the correct number with change value manually. You can test as many times as you want until the construction is finished. Beware that placing twice a cube at the same position, although visually okay, will not be accepted. If you are stuck or want to learn more, you can use the hints provided by the teacher beforehand. After you've read all the hints and still don't succeed, you can skip the task. After you press the check button, you can see whether failure or success. Accordingly, after you solve the task, you can go back to the list and move on with the next task. Now that you have all the app and the instruction, let's try it out. Please enter the code P416 into the app to start solving tasks. The first task will be the same as the breakout activity. And this time we will be able to try it out, the augmented reality feature, inside the app and get validation feedback. Why should teachers use educational application in class? Using an application can bridge between learning and gaming on mobile devices. This, along with the visualization possibilities, can increase motivation and collaboration. Students can use the app anywhere and also work on an individual level. It has an entertainment factor to use the app and to collaborate with others. It also saves time because students can receive immediate feedback. Computational thinking is a set of skills that are not only needed when dealing with technology. All of these skills can also be helpful when dealing with non-technological problems. Algorithmic thinking is the skill to come to a solution by clearly defined steps. A recipe, for example, can be interpreted as clearly defined steps. Automation makes use of the computer for repetitive tasks. Some repetitive calculations are done best using a spreadsheet, for example. Decomposition divides a big problem into smaller ones to conquer them. An example from mathematics would be to look at the factorization of a polynomial when wanting to calculate roots. For each factor, the root can be determined much more easily than from the starting polynomial. Hence, we decompose the polynomial into smaller factors, calculate their roots independently, and in this way, the roots of the starting polynomial have been determined. Debugging is not only the search for an error in a given code or algorithm, but also the systematic analysis of a code by going through each step and checking what it does. Generalization is the skill to take one result and to try to recognize patterns, to understand in which way this one result can be generalized to a bigger set of results. In mathematics, there are a lot of examples for this by simply looking at all of the formula. The process starts by one quadratic functions, calculating the roots using, for example, completing the square. After having solved this example, one might ask how this works with all the other quadratic functions. Going through the same process using parameters instead of numbers, one finds the quadratic formula. Abstraction reduces the unnecessary details of a given problem. In modeling tasks, this gets very clear. We look at a real-life object and want to do some calculation about it. We hence have to make a model out of this real-life object, and in the process have to decide which of the details we leave out.